Hello. Let's have a look at some answers to lasers questions. Right. Calculate the wavelength of a photon associated with the transition between U and G. Right. Energy of a photon given by HF. F is C over lambda. Rearrange for lambda, HC over E. The energy of a photon associated with that transition is the difference between those, just 2.26 times 10 to the minus 19 joules. Substitute all that in, you should get a wavelength of 880 nanometers. Explain in terms of electrons and photons what happens in the three possible processes listed below. So, absorption. The photon would just disappear and the electron gains its energy and move from G to U. You do need to talk about U and G in your answer. It's there in the question. Stimulated emission. 4 marks here. So, a photon of either this energy or that wavelength will cause an electron to drop from U to G, and when that happens, another identical photon is released. 4 marks. Spontaneous emission. An electron falls from U to G, releasing a photon. Blop. Photon comes out. That's a spontaneous emission. But the key bit is that's not stimulated. It just happens. It happens randomly. Some mention of something along those lines is what's required there. There is more on the other side. Explain what is meant by pumping in a laser. That's just when electrons are sent to the highest energy level, straight up to the top. Why is pumping essential? It creates the population inversion. That gives us more electrons in a higher level than the one below. And remember, we need that for the laser to work. And that's so that stimulated emission is more likely than absorption. Great. Let's have a look at the next question. Right, this one here. Right. Calculate the wavelength of the radiation emitted in the lasing transition. What's going on here? Oh, sorry. Right. You need to know where the lasing transition is. It's here. In a 4-level laser, this is the metastable state. The lasing transition is where the laser light is given out. That's when electrons drop from the metastable state. So we need to think about this transition. So the energy of the photons released is the difference between those. 1.87 times 10 to the minus 19 equals HF equals HC over lambda. Rearrange for lambda. You should get 1.06 times 10 to the minus 6 meters. What about the radiation needed for pumping? Remember, pumping is raising all the way to the top from the ground state. So we need that energy difference. Same method for finding the wavelength, HC over E. It's just a different energy. That's the energy required to pump the electrons. 7.9 times 10 to the minus 7 meters. Pumping is needed to produce a population inversion. State what is meant by a population inversion for this system. In bold. Well, there would be more electrons in U than L. More here than there. So you need to know where the electrons build up, where the population inversion is in a 4-level laser. Oh, right, there's more on the other side. Explain carefully why population inversion is needed for light amplification to take place. A population inversion ensures that stimulated emission is more likely than absorption. Stimulated emission is required, and that's because each event gives out 2 photons for 1 photon in. It's asking us about the light amplification. So we need more light coming out than what we put in. Stimulated emission allows us to have 2 photons out in each event for 1 photon in. 1 photon can knock an electron down, releasing another photon, and I've still got the original photon. And we need to have the stimulated emission being more likely than absorption. We don't want to reabsorb all of that laser light, so you have to have your population inversion. Right, why is it better for L to be above the ground state? L is an excited state. Electrons fall straight out of it, leaving it depopulated. There are virtually no electrons there. That makes it easier to achieve a population inversion. Right, so what we mean by that is this. For Pete's sakes. If there aren't any electrons here, I only have to pump 1 electron up to here, let it drop there. 1 electron, no electrons, I've got a population inversion. Easy, you only have to pump 1 electron. If that level didn't exist there, I haven't got a population inversion. I'd need to pump another one, and another one, and another one to get a population inversion. Much more pumping required to get a population inversion. Right, Doug Green signing out.